hey, 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 hola! Hello, my friend. Mr. Warrior here for another fun-filled math video. Yeah! And we have one of those really lengthy math videos as we have a lot of information to cover. I will do my very best. We're going to be solving real-world problems involving area of figures with fractional side lengths using visual models and/or equations. Here it says problem 1. It says the length of a flower bed is 4 times as long as its width. If the width is 3/8 meter, what is the area? Well, this is a big key indicator right here. Yes, we have 4 times as something else. We know in math that just computes to 4 times. If the width is 3/8 meter, what is the area? We can set up our equation. So I know that the length, it says, is 4 times its width. And I'm going to divide into fourths because if I know what the width is and the length is 4 times that, I could say that this would be my width, and then I need to make sure that the length is 4 times that. So that makes sense to put it into quarters. Now by modeling the mathematics, it kind of helps us work our way solving this problem. Because we're just, what we've done so far, we really haven't solved anything. We're just kind of setting our problem up. This would be like 1 times, because 3/8 times 1 is 3/8. This is 2 times as much. This is 3 times as much. This is 4 times as much. Okay, so now we have the width, now we have the length. So let's write this as an equation. So if we don't know what the length is, let's make the length equal to something then, for our sake of this problem. The length is equal to 3/8 times 4, and that's what we have up here. The m is just the measurement here. So I'm going to rewrite that as 3/8 times 4, which here you see 3 times 4 is 12 over 8. So here we can divide out a common factor. Looks like we could divide out a common factor of 4, and that's going to equal 3 halves. So now we know that the length then is equal to 3 halves. So we're going to take 3/8 then, and we're going to multiply that with 3 halves. And 3/8 times 3 halves is just, 9 over 16. 9/16. But that's going to be 9/16 meters squared. And we can't forget to get that squared because we're talking about square meters. It says Miss Linderman grows herbs in square plots. Her basil plot measures 5 yards on each side. Find the total area of the basil plot. Miss Linderman puts a fence around the basil. If the fence is 2 feet from the edge of the garden on each side, what is the perimeter? And then what is the total area that the fence encloses? So we almost find like the area twice. This square here represents the actual square plot that she has for basil. Now it also says that she's going to put a fence 2 feet around. And now this will show the fence that goes around her plot. Okay, just kind of want to get a visual of what I'm looking at here. So we need to find out the area here, because this is where she's grows her herbs. But let's take this step by step. Let's just keep it simple right now. Find the total area of the basil plot. Now we could do a quick little visual representation here. So we're basically taking 5/8 and we're going to multiply it by 5/8, length times width. In this case, all sides are equal. Well, we go ahead and multiply this. This is 5 times 5, which is 25, and then 8 times 8, which is 64. That's the area, 25 64th yards. Although that really doesn't make a lot of sense for us when it comes to when we do measurements. What we want to do is probably go ahead and change the yards into feet. So let's go ahead and do this. This will be an easy way to do it so that it makes sense to you. 5/8 yards really is, if you think about it, 5/8 yards is 5/8 times 1, right? And the reason why I'm doing that is because I'm going to multiply that by 1 yard. Now this unit is all yards, so we're fine because we have the same unit. So 5/8 times 1 is 5/8. What we can do now is we can go ahead and let's go and change that into feet by putting in how many feet are in 1 yard. I know a lot of you know that. That's 3 feet. So we're going to take 3 feet times 5/8 so that we can convert the 5/8 yard into feet. When we multiply that, we end up with 15 over 8. Now we've used our new unit, and that will equal 1 7/8. So now we have one of the sides, and all the sides are the same, so we have 1 7/8. We could determine the area by taking 1 7/8 feet times 1 7/8 feet. So now we multiply. It just so happens that 15 times 15, It's one of those really, I think it's 250, 225, and that's 64. We can figure out how many times will 64 go into 225. Kind of a big number. You can think of a lot. You can think of how many times will 6 go into 22. Almost 4 times. So I'm going to just say 3. And now I can see that 3 times 60 is 180 plus 12. So it would be 192. Be 192. How many would we have left over? 225. So we end up with 33. Now we need to look at Miss Linderman puts a fence around the Basil. If the fence is 2 feet from the edge of the garden on each side, what is the perimeter of the fence? What does this problem say? Well, now it's saying we know that each side here is 1 7/8 feet. Okay, this side is 1 7/8 feet. That's how we determine what that area was. But what the problem is saying now is that Miss Linda puts a fence. That's my green line. Here's my fence going around. The fence is 2 feet from the edge of the garden on each side. That means the distance here to this side is going to be 2 feet. And that means on each side. On this side we have 2 feet. So on every side we have 2 feet. Basically extended this 2 feet. So when you think about it, we've actually extended it 4 feet. We're extending it 2 feet on each side. We have 4 sides. So we extended it 2 feet here, 2 feet there, 2 feet there, 2 feet there. Hope that makes sense. So how would we solve this? Well, we already know that the length of one of the sides here is 1 7/8. So 1 7/8 feet is the distance. So we're actually adding on 4 feet. That's a simple problem. We just have to add on the whole part and then the fraction part. That means our new distance going here, new distance for this side is going to be 5 7/8 feet. That's from here to here. So this is the fence area. And then that means this side over here is going to be 5 7/8 feet. That's a little bit longer, as you can see from here to here. So I make sure you understand that. So we have 5 7/8 feet then on each side. So then we could take that amount then and just say, well, let's multiply that by 4. So let's take 5 7/8 feet, multiply that by 4, since there's 4 sides to this square. This is where all these math strategies really help. That's why we've been focusing on learning the distributive property. So let's take 4 times 5 plus 4 times 7/8. See if that isn't just a bit easier. Now we have 20 plus, and here we have 28 over 8. So we can make some holes here. Let's go ahead and just 20 plus. We get 24 with 4 left over, and then 8 plus 3.5, which is going to equal 23.5. And that's the perimeter because we were adding. And keep in mind, perimeter is side plus side plus side in a square is going to equal the perimeter. And a rectangle's perimeter is equal to 2 times the length plus 2 times the width. It just means you're going to take 2 sides of the width and 2 sides of the length. So that'll give us the perimeter. I like it. Yes, I do. And now it says, what is the total area that the fence encloses? Okay, now we found out the area of just the Basil plot of Miss Linderman. We hadn't found the area of the entire, so the area we didn't get is this part in here. Let's do the 5 7/8 then. And I think I might even do the area model for this one here, because that's the use of the distributive property. So we have 5 7/8 times 5 7/8. Now we have, what we need to do here is we need to represent this. This is 5 7/8, so I'm just estimating. I'm saying this big piece here seems like it's like 5. It's 5 whole pieces. He's not even 1, so I'm going to put my 7/8 down here. This is showing 5 plus 7/8. And I'm multiplying that. This is where this area model comes into play. And now I can do my partial products. This is what this is called. 5 times 5 is 25. And now we take 5 times 7/8, which is 35 over 8. Not a lot of room here to write, but I'll sneak it in there. And then down here we have the same thing. 5 times 7/8, which is going to be 35/8. It's nice this is a square. All our products are the same. And then we have this little corner here, and that's at 7/8 times 7/8, which is going to be 49 over 64. Now we just need to add up all these partial products. 25 plus we have 35 over 8 plus 35 over 8 plus 49 over 64. Yeah, I like the idea of putting this into a mixed number. So 35 over 8 is going to equal, so we'll get 4 3/8. Okay, this is just that number represented as a mixed number. Plus, I'll write it all out so you can see it. Can I do that? 4 3/8. Can you see that? Plus 4 3/8 plus 49 over 64. I'm going to have to come over here so you can see where I'm going with this. Now I have my 4 3/8 and 4 3/8. Well, that's 8 6/8. Go ahead and put that down. So 25 plus 8 6/8 plus my 49 over 64. Now I'm going to get that common denominator. That's going to be 64. And 8 times 6 is going to be 48. Can't forget my 8 in here. Let me get that in there. Plus 49 over 64. And I'm going to add him on there now. I'm getting 33 plus, and 40 plus 49, what does that look like? 97. 97 over 64. And that's going to make at least one whole. So that's 33 plus, let's just do 64 over 64 so you can see that. And the difference looks like it's going to be 33. And so that's going to be 33 over 64. Lengthy, huh? Now I have my 34 because I can add this on here. That's plus 1. 34 with 33 over 64. And we were finding area, and this was in feet squared. Whew! Liking that. Now it says we have Nicole bought 5 yards of fabric, 2 1/4 feet wide to make curtains. She's the seamstress, I guess. She used 1/3 of the fabric to make a long set of curtains, all right, and the rest to make 4 short sets. Okay, we have 2 things we need to do. It says we have to find the area of the fabric she used for the long set of curtains. Okay, we're looking at area. And now here also we're finding area of the fabric she used for each of the short sets. It does say she made 4 short sets. Kind of want you guys to think that, this is like our figure here. So we have 5 yards. We have 2 different unit of measures. We want to get that in one or the other. I think we're going to go into feet. So kind of think of like this as being the 5 yards, and then this is the 2 1/4 feet wide. I think what I'm going to do here is first figure out what the total area of my fabric is, because we have 2 feet and we have 1/4 feet going this way, right? And then the only other distance is we have the 5 yards. Because there's 3 feet in 1 yard, we can take 5 times 3, 15 feet. Now I have 30 feet in here because I took the 15 times 2. Now I can take the 15 times 1/4, and that's 15 over 4, but we're going to quickly change that into 3 3/4. Then that would mean that my total area of the fabric would be 33 3/4 feet squared. That didn't answer our question. It just says find the area of the fabric she used for the long set of curtains. Well, it says that she used 1/3 of the fabric to make the long set. So we need to take this now, and we need to multiply that by 1/3 because we're trying to find 1/3 of that amount. She didn't use all of it. So we'll do 33 3/4 times 1/3. And distributive property would really come in handy, I think, on this one here too, because 33 times 1/3, yeah, I think I would like that. So I'm going to put 33 times 1/3 plus 3/4 times 1/3. This here would be 11, because 33 divided by 3 is just 11. That's nice. So 11 plus 3/12, which of course would be 11. And let's just go ahead and change that into 1/4. We divide that, and that's going to be feet, and that is going to be squared because we were dealing with area. This was all area here. We just found 1/3 of that area. So for this one here, we're going to say then the area of the long curtain is, and we already have that, 11 1/4 feet squared. Okay, and we just solved A. So we found the area of the fabric she used for the long set of curtains. So now let's look at B. It says find the area of the fabric she used for each of the short sets. Well, let's go back to the problem and take a look what we need to solve here. And it said the rest to make, so she used 1/3. She used the rest to make 4 short sets. We need to know what the rest is. If she used 11 1/4 feet, we're going to want to take our total then, 33 3/4 feet. And we're going to subtract that 11 1/4 feet. These are nice easy numbers, huh? 22. I like it. And then we have 2/4, which is 1/2, right? Now we know that's what's left. Now we need to make 4 short sets out of that. Well, the easiest way to find that, I believe, is if we're talking about the short sets and there's 4 of them, we can always kind of think, Well, it's this amount divided by 4, which is like we're actually asking then if we can put this in a multiplication sentence, is it's going to be 22 times 1/4. Because by finding a quarter of that is the same thing as we've learned earlier of taking 22.5 divided by 4. And since we really haven't talked about dividing fractions, only multiplying them, we're just going to switch that around. And much easier to solve it this way, to be honest with you. Now again, this is where the distributive property would be great. Plus 1/2 times 1/4. See, all I did was first I took the 22 multiplied by the 1/4, and now I'm taking the half times the 1/4. Plus 1/8. I want to take out that common factor right away, which is 11 over 2 plus 1/8. Right, 5 will go in there, 10 with 1 left over, plus 1/8 is going to equal 2. We get a common denominator for that. And that's going to be, what, 16? So 16, we're talking that's going to be 8/16 plus, and here we have 16, which is 2/16. And I'm going to come up here. That means I have 5 and 10/16, which is equal to 5. And we can divide out a 2, 5/8. Mega work. Now we can write this as a statement here as well, which is that we can say the area of each set of short curtains is 5 and 5/8. Let me write that down. So the area of each set of short curtains is 5, and I said 5 and 5/8 feet squared. Make sure you have that squared when we're talking about area. Okay, wow, what a mega problem. We have all wire is used to make 3 rectangles. Right, A, B, and C. Rectangle B's dimensions are 3/5 centimeters larger than rectangle A's dimension. Okay, so right off the bat we can say that rectangle B, I'm going to put rectangle B is larger than rectangle A. And rectangle C's dimensions are larger than rectangle B. Okay, and I'm just going to put C is greater than B. Rectangle A is 2 centimeters by 3 1/5. It's like, okay, mega problem, challenging, of course. It wouldn't be fun if it wasn't challenging. So rectangle A, B, and C. So we have 3 rectangles. But we already, without really doing any solving of any kind, we can look at this and try to get a good understanding. Here, rectangle B, we know is greater than rectangle A. It says so. It says its dimensions. Its dimensions is its width and its length. It says that it's 3/5 centimeters larger. Not a lot larger, but it's larger than rectangle A. And the other thing that we learned is that rectangle C is larger than rectangle B. So if C is greater than rectangle B, then that also means C is greater than rectangle A. And this is just kind of a concept, logical thinking, some good logical reasoning, that's a true statement. Now we have the dimensions of rectangle A. So what we're going to do is by finding rectangle A, then we'll be able to move to find rectangle B and rectangle C, one by one. Okay, so first thing, since we have rectangles, let's get some rectangles and model this. We know that rectangle A, so let's label these. So A says it's 3 1/5 by 2 centimeters, so that's going to be the length. How do we figure out B? Well, it says that B's dimensions are 3 centimeters larger than rectangle A. Okay, so let's attack the problem this way. Let's go ahead and get the area, and that's going to be 2, right? 2 centimeters times 3 1/5. We'll go ahead and use the distributive property to solve that. We have 2 times 3 plus 2 times 1/5, which is equals 6 plus 2/5. So we get 6 and 2/5 centimeters squared. Ooh, Mr. Ward, don't forget that. Now for B, it says that the dimensions are 3 centimeters larger. And that means larger this way and larger that way. It means it's going to gain 3/5 centimeters this way and that way, if we're going to say larger. So let's do that. That means that this dimension here is going to be 2, not just 2 centimeters, 2 and 3/5 centimeters. And then this one's going to be 3, if we were to add on 3/5, well, 3/5 plus 1/5 is 4/5. So that's going to be 3 and 4/5 centimeters. We have 2 holes and 2 smalls. So I'm going to just draw my area like this. I'm going to put my 3/5 down here. And that's just showing that this whole section here is 3. This is 4/5. All right. So now we have, first areas, we got 2 times 3, which is 6. We have 2 times 4/5 here, which is 8/5. We'll change that later. Now we have 3/5 times 3, which is 9/5. And then we also have this little corner, which is our 3/5 times 4/5, which looks like that's going to be 12/25. So let me write this out so we have it all together. 6 plus, I'm going to change this now, which is 1 3/5, plus 9/5, which is 1 4/5, plus over here we have 12/25. Okay, so now it looks like I have another, so I have 8. It looks like I have another whole here. So I have 5/5 plus 2/5 plus 12/25. Now here I can use another whole here. So I have 9 plus 12/25. Find the common denominator. So we have 25, which is 10/25. We just put the 9 here. Plus 12/25. So I end up with 9/22/25. Okay, so we found the area of rectangle A. Now we found the area of rectangle B. Now what does C? C says that the dimensions are 3/5 centimeters larger than rectangle B. So because we figured out rectangle B, now we can figure out the area of rectangle C. We'll go ahead and, well, here I had 2 3/5. I'm going to need to add that on. One side was 3 4/5. I'm just going to write this down here. That was the length. And the width was 2 3/5. That's the width. Now I need to increase that by 3/5 centimeters, which 4/5 plus 3/5 equals 7/5. And 7/5 we already determined was down here, which was 1 2/5. And we're going to add that on to the 3. So that means I should have 4 2/5. So I took the 7/5 from this right here. I'm just adding that on to the 3. So 4 2/5. So I'll put a 4 here and 2/5 here. And then I need to add on 3/5 here, which is going to be 6/5. And 6/5 added on to the 3/5 is going to be 1 1/5. And 1 1/5 added on to my 2. Now I have 3. That way I can figure out the area of that last rectangle. Now this is easy. 12. This becomes 4/5. This is 3 times the 2/5, which is 6/5. Which we can change that right away. And now we have 2/5. That's going to be nice. 2/25 looks like. Now we just add them all together. 12 plus 1 1/5. These numbers are a little bit easier to work with. I'm just going to add that on here. 13. And, ooh, look at this. 13. And I have 1/5 and 4/5. That's going to make a whole. That's kind of nice. So that's just like saying, I should place 14 altogether. I put 13 plus 1. 2/25. Now I get 14, 2/25. Now one would think, oh my goodness, all that work, we're finally done. Well, not actually. It's just the total area of all 3 rectangles. So now we need to add all those together. You know, have you noticed the last problem they have in the set is always like the mega problem. Okay, we have 6 2/5 plus 9 22/25 plus 14 2/25. Well, let's change this one in here right now. 5, we'll make that 10/25. So 6 plus 10/25 plus 9 22/25 plus 14. And, you know, I know that some of you may be watching and going, Mr. Warrior, you know, you putting all these steps down, you know, you could do a lot of that in your head. But, you know, it's actually a good idea to always write every step down as much as possible because you're less likely to make a mistake. So now I can add, I'm going to add all my whole parts. So 6 plus 9 plus 14. That looks like what, 23? Looks like 29. And now I can add all the rest, and that's going to be 10. That's going to be 32 plus 2 is 34/25. Now you can see I can still make another hole here, so I'm just going to write it like I have been to show you that there's a 1 hole in there. And then, of course, what do I have left over? Looks like 9 plus 9/25. So now we end up with 30 and 9/25. I don't know, does that sound right? Now this is my answer reasonable. Well, here adding those all together, yeah, those numbers, it's about 30. Fairly good estimate. Wow, what a problem. And that was just A. Oh my goodness. So we have yet another problem. Here, if a 40 centimeter coil of wire was used to form the rectangles, how much wire is left? We'd have to know perimeter because this isn't square. This is just, it's a long, wires along like a string. So this isn't giving us area, this is just giving us length. So this, we could kind of take a perimeter going around And we need to find out the perimeter for each one of these rectangles, which might be easy. So now let's think. So we have 40 centimeters. The perimeter here is going to equal 2L plus 2W. That just means if I can find the double of each one of these sides, because 2 centimeters, we have all right angles. So that means this 2 centimeters, we have 2 centimeters over here. So that is going to equal, so 2 length is double that, which is going to be 3. So I'm going to write it like this. 2 times 3 1/5 plus 2 centimeters times 2. Okay, I was still thinking, because I usually don't use x's for times, but that will work. So now here, we're going to use the distributive property and show that is 6 plus, and then 2 times 1/5, which is 2/5, plus 4. So I'm going to put 10 and 2/5. Now, next one. Same thing. So perimeter is going to equal 2 times 3 4/5, 2 times 2 3/5. And let's see if we can just kind of do this in our head here, save us some room. So 2 times 3 is 6. 2 times 4/5 is going to be 8/5, which we're going to put right now as 1 3/5, plus, now we have 2 times 2, which is 4, plus 6/5, which here we know is 1 1/5. Now we can add that 6, we get 7 3/5, plus here we have 5 and, oh, just the 1/5. So we have 12 4/5. 2 times 4 2/5 plus 2 times 3 1/5. And here now we have 8 plus 4/5. I took the 2 times 2. That's what I'm doing. Now 2 times 3, 6, and then 2/5. It's a little bit easier to figure out. All right, 14 and 6/5, which is equal to 15 and 1/5. All right, now I can add these all together. I'm going to write them vertically so I can see them this way. Plus 12 and looks like 4/5, right? Is that what I wrote down there? Yeah, I think that's a 4. Plus 15 and 1/5. Add all these together. So here right now you can see we have 7. Here we have 4/5 and 1/5. That makes another hole. So let's just add 1 over here. That takes care of this, right? And then we have 2/5. Makes it a little bit easier. So we should end up with 38 and 2/5. And where unit is centimeters, that is not squared because we're going after perimeter. And how does that sound? Okay, but what's our question? Our question says, how much is left? Okay, not how much is all together. So we had 40 centimeters. All right, this seems real. Minus 38 and 2/5 centimeters. We'd need 3/5 to make one more hole. I like to count up, like you guys do on your fingers. So 3/5 makes 39, and then you'd have one more. So 1 3/5 centimeters left. Okay, that should do it. Oh my goodness, what a mega video. You guys, I'm going to cut you loose. Thank you again for focusing on such challenging problems. Now, live on this problem.